My name is Daniel Limanowski. I'm the media chair on the cabinet for IASG. If you've seen me before, I've probably been behind the camera. What I do is kind of run the YouTube channel and edit and upload the videos, as well as produce any sort of media advertisements for the club. But enough about me. So today I'm going to be talking about packet sniffing, more specific wireless packet sniffing with Wireshark. And so up here, I've got a wireless adapter with a kind of too big of an antenna almost, but we'll be talking about that. Okay, so in case you don't know, packet sniffing in general is, if you look at the definition I posted there, the process of capturing any data passed over the local network and looking through that information for anything that's useful to you. So essentially, you're capturing the data on a network, and you can look at the different representations of that data and the different protocols, and it can be used for a lot of different purposes. Some of them, what I would guess is the primary reason is network troubleshooting. So if you're having an issue with your network, it's a great way to find out what's happening at all levels of the network. It can be done locally, so just the information that's going to and from your computer, or you can sniff the whole network. Obviously, it can be used for bad purposes. If you are looking to perform some sort of an attack, you can eavesdrop on people, capture data to use as intelligence for some sort of attack. So it does have that kind of black hat side to it too. So there's a lot of different purposes you could do packet sniffing to. And I do want to reiterate, it can be done wirelessly and wired, depending on how you set it up. So how does it work? To sniff your own traffic, all you need is your computer and Wireshark or some sort of application or package that can perform that task for you. To actually have some fun and look at a wider array of data coming from a lot of different devices, you need some sort of wireless adapter that has monitor mode. So I'll stress that part. If you can't put it in monitor mode, you're really only going to see the data from your computer and whatever that's contacting. So I've got here, this is the alpha some long string, and at the end says NHA. It's a wireless adapter, USB. This antenna came with it. I paid a couple extra dollars for that. But they're pretty cheap. The one I have pictured here is the NH version. IASG actually rents these out, so if by the end of the presentation you're interested in kind of playing with this, you can check those out for free. So if you want your own version or your own to keep, they're relatively cheap on Amazon. You can find them with $30 to $40 for that version, and it does everything you need to get started with packet sniffing wirelessly. So before we start, is this even legal to do? I had to do a little bit of research to find this out, but it's a yes or no kind of answer. It varies by case. So in 2012, a judge from, I think, North Illinois ruled that wireless sniffing on public open networks is legal because the expectation is that it's public and open, and the signals are going everywhere and anyone can pick them up. So if you are on an unencrypted public network, it is legal to sniff packets. Now, it starts getting into the gray and illegal zone when you're on an encrypted network, when you are putting in, like Wireshark, you can actually put in the password for an encrypted network and start sniffing packets. That is not suggested. One that wouldn't be is EDU roam, because that's encrypted. So the takeaway that I want you guys to get from this presentation, if you don't learn anything else, is to stop using ISU Cardinal, IA State, ISU Guest, because those are all open. And we'll take a look at the kind of data that we can look at. But essentially, most of that data, unless you're using an encrypted protocol like HTTPS, is open for us to look at. So, but we'll take a look at just what kind of data we can find on an encrypted network. So yeah, get on EDU roam if you're not on it. I think it's your net ID at IA State and then your password to log on. It's super easy, and it's available at most places on campus.
And across the globe too.
And across the globe, yeah. So I visited my girlfriend at University of San Diego, and they had it connected right away, and I had Wi-Fi, which was pretty awesome. So yeah, what are we going to encounter when we do this sniffing? So in Wireshark, it displays the data in a variety of ways, but you get to see the different protocols that the packets make up. So I'll talk about some of the common ones, but there are so many that you could encounter. It's kind of ridiculous. So we'll just talk about some of the common ones that might be interesting to us. So first one, we have HTTP, stands for Hypertext Transfer Protocol. You probably have seen that if you've ever used a web browser. It's on the application layer, and it is the primary form of communication for the World Wide Web, the internet. So there's HTTPS, that's the secure version, it's encrypted, and we'll look at viewing HTTPS packets and what that looks like for us on the sniffing side. So continuing on, ICMP. So this one is used by network devices and routers on the network that are talking to each other. And if you've ever used a ping command, that generates an ICMP packet. So if you've ever done ping, I don't know, 199.100.16.100, you are generating an ICMP packet. So that's a really good way to troubleshoot network issues, is looking at the ICMP packets. Additionally, we've got UDP. That's on the transport layer, and that essentially is what I like to consider the fast version of TCP, but we'll get into TCP in a second. It essentially sends connectionless messages, so there's no guarantee that the packet's going to get there. If it gets dropped, it gets dropped. Keen has told me this in the past, where Skype uses UDP, I believe, and so if you see the glitches that you see when you're video chatting with someone, it's usually because of UDP packet drops. Whereas TCP, that's also on the transport layer, but you have guaranteed delivery of the packet. So it's going to get there, and sometimes you have bottlenecks with those packets because you do have that guaranteed delivery. And like I said, those are only a few, but we don't really have time to talk about all those, and I don't want to bore you guys. So what else can we encounter? So we see the protocols. We also can see plain text traffic. I was sniffing over near my apartment this weekend, and I was actually seeing some IRC chat traffic. So I could see what people were chatting back and forth, which is kind of crazy. Images, plenty of images to download. If it's not encrypted, you can find it, and we'll look at a cool way to essentially look at all the images that we've captured over however long we've sniffed for. Web URLs that people are connecting to and getting data to and from, and encrypted packets. And essentially, you'll see a lot of these, and these are basically, the only reason we're seeing them is because the header of the packet is unencrypted, but the rest of the payload is encrypted, and so it just displays as 802.11. So for example, if you're browsing a website that's using HTTPS, all we're going to see is that 802 protocol and some other data that's not very interesting or helpful to us at all because it is encrypted. So technically, that's a good thing. OK, so we're going to see how this goes. You said you have Wireshark installed on this? OK. I don't know if I'll be able to get the adapter I have here working. If not, then I know there's some sample PCAPs we can look online. But if you do have Wireshark installed, or you want to install it real quick, it's on pretty much every operating system, every primary one, main one out there. So if you want to download that real quick and boot it up, we can kind of follow along together. But I'll go ahead and get that started.
Windows type Wireshark.
Yeah. OK. So is there, do you know if we can get this working and out there?
Already.
Oh, it is.
Yeah,
so it does work.
Here.
Awesome. Thank you.
It's
OK.
WLS.
OK, perfect. So sorry, it's kind of small here. But essentially, when you open up Wireshark, this antenna is way too big. When you open up Wireshark, you see the capture window here. You can enter, this says using this filter. You can enter a capture filter, which we'll talk about later. And down here, you've got all the different devices that your computer is recognizing as networking adapters. So we've got this WLX, which Keen has told me is the adapter. We put it into monitor mode. If you want to monitor or sniff packets that are going around, you need to make sure you put your wireless adapter in monitor mode. Not all of them support it. So That's why you guys should check out the alpha cards that we have if you're interested, or you can always see if your adapter does have support for monitor mode, but chances are if it's in your laptop it won't, but you can always check. So I'm going to go ahead and just double click this, and hopefully it starts showing something.
What did you double click? W10?
Yeah, it should have been, okay.
So it's currently on channel 6.
Okay.
You don't want to change that under view.
Yep.
I don't know if channel 6 is used here.
Oh, it's on channel 8. I know channel
channel
6
8.
and channel 1 are the big ones. Okay, so as you can see here, we've got some packets that are starting to come in to Wireshark. If we can scroll down, maybe we can catch up here with them. Nope. Okay, 1 second here. I'm just going to go ahead and stop this.
Are we using the adapter for this? Yeah.
So I have been running this for, I don't know, 30, 45 seconds now. We've already got a ton of packets coming in. So what I like to do is I stop the packet capture, and I'm just going to continue without saving. In here, you can enter capture filters. So essentially, Wireshark has two different types of filters. There's capture and then display filters. So capture filters are essentially going to let you choose what type of packets you want Wireshark to capture. So I'm going to go ahead and type the not keyword, and then if I enter broadcast, it's just going to basically reject any broadcast packets. That way we don't get cluttered with those, because those really aren't interesting to us if we're looking at doing some sniffing here. So it turned green because it recognized that as a proper capture filter, and I'll go ahead and hit start again. So that just kind of clears out our screen. So I'm going to let this go for a little bit, and we can see if we can find anything cool. But up here, it says apply display filter. So this is cool. You can basically filter out different specific protocols. So if I wanted to specify by HTTP, I can do that. It looks like we haven't captured an HTTP yet. I can go ahead, and another cool thing is under the view, if you click wireless toolbar, you can specify the channel that you're operating on. You'll have to look up how to do this on your own because I can't show you today, but essentially you can look at what channels have the most activity on and go to that channel to have higher chances at capturing more packets. So it looks like we're getting some HTTP. We've got some GET requests here.
I think it's the IASG homepage.
Okay, yeah. These look like some JPEGs. So now that we've captured some data, I'm going to go ahead and hit stop. So we do, if we scroll down, we've got a little bit of HTTP. So I'm going to go ahead and just show you this cool trick that I found out. If you go to, so you can click on a specific packet to look at the information that is associated with it. And this one is showing that it is a JPEG. So we've got the address here, and then obviously the file name there. So what's nice is if you want to look at the different objects that Wireshark has captured, you can either go through all of these and look for it one by one, or you can go up to File and then Export Objects, and we can export by HTTP. So this pops up a screen essentially that just shows the different objects, so not packets, but objects. So we're talking JSON, JPEG, GIFs, text files, etc. So just kind of the interesting stuff that you might capture. So do you mind if it's from IASG, you mind if I save it? Okay, so we can click on one, or we can save all, but we're not going to do that to Keen. So we'll just click Save and Desktop, okay? Okay, so we'll save it to the desktop, and hopefully we can see this one. Okay, let me get out of here. Okay, so, all right. Looks like it's not gonna let me do that. Okay, so, yeah. All right. File. So export objects, HTTP, and then you can save all. So I guess we'll do that. We can erase them later. So we'll see if we can get any images here.
So you just downloaded all the images that were in that packet?
Not that packet, in the entire capture. So those are all the objects that we captured in the last, whatever, 1 minute, 2 minutes. So you know, sometimes it gives you issues with these. I've not had that high of a rate of being able to see the images, probably like 1 in 4. So it looks like it's not letting us look at any of these. Sometimes the extensions can be wrong, but I'm not going to waste time playing with that. So what I am going to do, if you guys want to do this too, Wireshark has some example PCAPs. And so PCAPs are essentially the data file that Wireshark saves to when you do a capture. So if you go to the sample captures page, and we find, I know it's tiny here, HTTP. There is one here, HTTP with JPEG. So I'll demonstrate how this works because I want you guys to be able to see it. So if you want to do it on your own, you can. So I'm just going to go ahead and extract that. And we'll go back into Wireshark here. And then we can do File, Open, and
What operating system are you on?
so this is Debian. I don't know, what are you on? Like, you on Stretch or what?
Yep, Stretch.
Okay. All right, so I opened that PCAP. So now this is just a very basic example, and it doesn't have much, just some HTTP and images. So if we go back to what we were trying to do before, we can go to File, Export Objects, HTTP, and looks like we've got an image here. So we can go ahead and try to save that to the desktop real quick. And so that. Okay, and then that was the image. So if we had time to run it longer, I could pretty much guarantee that we could find some sort of image that would work. I really wish I could show you the ones I captured on my computer. Unfortunately, that's not working. I should have tested that before. But yeah, so that kind of gives you an idea of how to go about capturing data within Wireshark. We can go ahead and capture some more. We'll get rid of this display filter.
You've got a question.
Oh yeah, sorry, go ahead.
Is there an API for Wireshark so you might create scripts kind of like help like automate scripts?
Yeah, good question. I believe there is, but I don't know for sure.
Yeah, a little bit.
Okay. So, yeah, I know there's also command line, not version of Wireshark, but I think Wireshark might be built on it. It's called T-Shark, so I'm sure you can run scripts using T-Shark. So it might be something to look into as well. So yeah, I'll go ahead and stop this again. Yeah, go ahead.
Just a question.
Sure.
Have people created their own kind of Wiresharks before?
Yeah, so I know, and you guys can kind of chime in on this, but I think I was reading the syllabus for one of the 500 level classes.
530.
Don't you build one of like a packet sniffer?
Simple packet dissector that prints out what protocol the packet is you receive and what the payload is and all the information about it. So that's sort of a simple thing you get to build as part of the class, Computer 530.
So possibly you can download that on a USB file. Just creating a program and making an executable from a USB.
So essentially being able to make a payload to plug a USB in a computer and sniff traffic?
Yeah.
Mm-hmm. Yeah, I would say that's possible. I know Hack5 has a, I think it's called the USB Rubber Ducky, which lets you run executables in a, looks like a USB. And I would not be surprised if that's been used before. So, so yeah, up here we can filter by protocol or sort by protocol and take a look at the different protocols that the data that has been around is showing. So a lot of the 802.11s, let's scroll down here. So we've got UDP, which we talked about before, some TCP, and some protocols that you would have to read about on your own. But so yeah, there is a lot of information to be learned, especially if you're trying to troubleshoot issues on your own network or just from your computer out to whatever you're communicating with. So this is something that you can go ahead and start doing even if you don't have a adapter that supports wireless mode. You can look at your own data by just capturing on your wireless card. So if I were to click WLAN 0, then I would just be capturing the data into and out of Kane's laptop here. So let's go back to the presentation real quick here. See if I can get this up. Okay, so how do you protect against being sniffed? We've seen how easy it is. Anybody can really do it. Apparently even laptops have the monitor mode already in them, the Lenovo ones. So this is accessible to everyone, and it's really easy to do. So how do we stop this from happening? Well, the first and primary measure that you should take is not to use unencrypted Wi-Fi networks. So getting off the ISU Cardinal, being wary of phones automatically connecting to coffee shop hotspots and whatnot. If you have to use an unencrypted network, use a VPN service. I know people in the past have made their own, or you can pay for them. I'm not sure if there's free ones that you could trust, but VPN is a way to go if you have to use unencrypted networks. You can ensure that the sensitive data you're sending over the network is encrypted. So when you're using a web browser and trying to make a purchase online, make sure you see that green icon, that green lock in the corner that's showing that you're using HTTPS. Bless you. So yeah, and another tip, obviously make sure your passwords aren't all the same. So if you start using an unencrypted network, or if you realize that the HTTPS website you were using turned to HTTP and you just click submit, making sure that you're not using the same passwords for all your accounts can help in case an attacker gets one password. A lot of people will, I've done this in the past, use the same password for a couple things, and if they get it on one, they can pivot to different accounts. So using a password manager is a great idea, keeping those passwords separate for different accounts. So with that, I think that's all I have for today. I would have been able to demonstrate more, so I apologize for that. But if you guys have any questions, I'm open. So thank you, team, again. But yeah, for real, do you guys have any questions regarding packet sniffing? Okay, cool. I'll be here for a little bit after, so if you do want to come up, got a question in chat, I'll be here. So yeah, thanks a lot for your time.